operation intensity transformation we have studied, right? In the laboratory this week, we are going to implement them. We completed gamma correction last time. Okay. Now today we will start with some other transformations. One of them is piecewise linear transformation. Okay, from the name, if you will see, it is very easy to understand. It is a linear transformation. Can you understand the meaning of linear transformation? How input and output are related with? If it is a linear transformation of an image, of an input image, then how input and output are related with? They are related with one equation of a line. That you can understand from a linear transformation. Now that linear transformation can be of this type, can be of uh, this type, it can be of any shape of this type. These are the linear transformations, right? Where input is related with output, I will say it is output O, or rather I should say it is R and this is S, right? And so this is the linear transformation. But one more word we are having here is it is a piecewise linear transformation. Can you understand the meaning of piecewise linear transformation? What do you think what it will be? What is the significance of piecewise word that you can get from? It is linear in certain location. Otherwise, I mean, it is linear everywhere, but it is represented by a equation of a line in certain region and other equation of a line in another region. I can show you. Like from this is my input image R. This is my output image S, right? And I have this values. Input will vary from 0 to maximum value is L minus 1. Can you tell me what will be the value of L minus 1 if n is equal to 8? That means if I am representing image using pixel 8 bits per pixel, what will be L minus 1? Quickly. If n is equal to 8, 254 or 255? Those who are saying 254, who said so? Rahul and Devang. Want to correct? It is 2. See, L is 2 raised to n. L is 2 raised to n. Understood? So it is L is 256 and hence L minus 1 is 255. Is it, yes, Rahul is, I think, clear with Devang. Are you clear? Okay. So L minus 1 is 255. Keep in your mind that L is 2 raised to n. Okay. So what we are having, I have different intensities from 0 to L minus 1. Out of that, up to value R1. That R1 can be of any value, that is up to, that is your choice, right? R1 can be 30, 20, 100, 150. That can be your intensity value, or certain intensity value which is between L0 to L minus 1. Arbitrary value which is between 0 to L minus 1. For 0 to R minus 1, I will represent, I mean 0 to R1, I am going to represent this transformation using certain equation of a line. Then R1 to R2, right? From R1 to R2, I have another equation of a line. It is not looking like, wait, it will look totally different. So, I mean, it may look totally different. It can be same. That's okay. Here you can understand a straight line. You can feel like it is a straight line. Okay. Assume this is a straight line, right? It is not a curvature at all. And then you might have from R1, R2 to L1, again there is a piece and you have another equation of a line, kind of thing. So from this region to this region, there is one equation of a line. In this piece of input, another equation of a line, and in this piece of input, another equation of a line. So that is what piecewise linear transformation is. Okay. Now, in the piecewise linear transformation, you can implement the three different operations. You can perform these three different operations using this piecewise linear transformation. Okay, one of them is contrast stretching. Now, first of all, tell me, let us go to initial image. I told you certain image is very much useful to us, and here, which one is left image or right image is low contrast image? Left or right is a low contrast image. Contrast image? Yes, left is low contrast image. Okay. Now, yes, left one is a low contrast image. Now I want to stretch the contrast. I want to enhance the contrast of it. Okay. So what exactly I am having here? Can you tell me what are the intensity ranges? Suppose one image is having intensity range from say but so I have two images, right? I have two images. One image one is having intensity range from say 50 to 100. That means minimum intensity present in the image is 50, maximum intensity present in the image is 100. Though it can take values from 0 to 255, where 0 represents black and white is represented by 255, right? This is the possible values, but in my image, intensity available are 50 to 100, and image 2, I have the intensity available which are say say 0 to 255. All the intensities are present, right? All the possible intensities are available in the image, right? Can you tell me in which image one or two will be a low contrast image? Which image one or two will be low contrast image? Observe why this is low contrast, and according to that you can answer here. Yes, one is low contrast image. Why so? Because here if you will see this is low contrast, by looking at that you understood, but here if you will observe why you are feeling so it is low contrast, because here this white color which is available here, this black color which is almost black, I am not saying it is exactly black, which is here dark gray, and here it is a bright gray, right? And that's why you are feeling like here we have a just gray color in this region, here we have a white color in this region, and that's why this is looking like a better image. Why? Because available range in the of the intensities are larger here, right? And while here in this case what we are having, what we are having here, the available range of intensity is lower. Okay, now what I want to do is, suppose here my intensities are available in the range from R1 to R2, that is 50 to 100. Now what I want to do, I want to apply transformation such a way that R1 maps to what and R2 maps to what. The range R1 to R2 should map to certain range so that contrast is enhanced, right? In this image, my intensities available are R1 to R2, like it can be 50 to 100. I want to enhance its contrast. So 50 should be mapped to what? 100 should be mapped to what? And intermediate value should be mapped to which value so that contrast is enhanced. Just tell me about the endpoints, intermediate values we will discuss later. R1 should be mapped to what and R2 should be mapped to what so that it might enhance the contrast. What is your take? If input is 50, what should be my output? If input is 100, what should be my output? What is the significance of having value 100 here? Suppose this image is this itself. Assume it that it is having intensity range from 50 to 100. That means, can you tell me about this? Suppose this is the darkest region here. What will be the intensity of this? If I say this is the darkest region, what will be the intensity of this region? If it is having value 50 to 100, Harsh, it should be 0, right? But here what I told, yes, it is 50. You are clear with me? Okay, then no issues. Okay, so this should be 50, right? This should be 50. Okay, and this, if I say this is the brightest region, what will be this values? This is the brightest region, it will be 100. Now, if I want to enhance the contrast, what I need is, yes, R1 should get mapped to 0 and R2 should get mapped to L minus 1. Should I write L minus 1? So that it will be more generalized on, yes, 255. R2 should be mapped to 255. Or rather, I should say R2 should be mapped to L minus 1. All of you are comfortable with this? Are you comfortable with this point so that I can move ahead? Otherwise, I have to discuss this. Clear, no? Okay. Now, how the transformation will look like? So, this is my input. This is my output, right? In my input, which intensities are available? Do I have values from 0 to R1? Do I have value in my image from 0 to R1? No. So I don't have. So whether it is there or not, if it is not available. So it actually they are not defined here at all. Okay. Then do I have value from R2 to L minus 1? In my input image, do I have value from 0 to L minus 1? I don't have values from 100 to 255 as well, right? In my output, what I desire, I want it should be like L. In output also I am having L minus 1 value, right? Okay. Now what is my desire? That R1 should get mapped to what value? As Priyank suggested, what was that? Yes, R1 to 0. Yes, R1 to 0. So where that point will lie? That point will lie here itself. R1 is mapped to 0. What about R2? Where it is mapping to, it get mapped to? It get maps at L minus 1. So R2 will get mapped to, this R2 will get mapped to like this. So this is what the transformation that we desire. Intermediate values should get mapped accordingly. Is it clear? So so here, can you see the piecewise transformation here? Here they are not existing, otherwise you can see it like this, you can see it like this. And it will not make much sense because they are not existing actually. So in case they are, map them to L minus 1, but they are not. Can you see piecewise linear transformation here? This is a simple piece, this is another piece, and this is third piece. Understood? So this is a special case of piecewise linear transformation. What was piecewise linear transformation, if you remember? The diagram was looking like this, right? So in that, this R1 was mapped to S1. This R2 was mapped to certain S2, right? And this L minus 1 ultimately, of course, need to get mapped with L minus 1, because if it is 8-bit and if you are desiring to be it 8-bit only, then you are going for that only. So this is generalized diagram of a piecewise linear transformation. Now, if I want to convert this generalized diagram to contrast stretching, can you tell me what should be the value of S1 and S2? If I want to convert this generalized diagram to a specific contrast stretching diagram, can you tell me what will be the value of S1 and S2? What is S1? Yes, S1 is 0 and S2 is L minus 1. Okay, now true. That is fine. That is absolutely correct. Now one more special case I will let you know. So all of you are comfortable with, I'm assuming, that all of you are comfortable with contrast stretching. Those who are not clear can stop me right now. Any doubt? Okay. So now tell me, if I take S1 is equal to 0, S2 is equal to L minus 1, and R1 is equal to R2 is equal to K. Which operation is that? S1 is equal to 0, S2 is equal to L minus 1, R1 is equal to R2 is equal to K. Think and tell me which operation is this. No. Think, Harsh. Try to plot. Yes, it is thresholding. Try to think, all of you. Try to visualize it. It is a thresholding operation. I can show you that. Okay. What I want, S1 is 0. So first point is 0. Another point is going to be L minus 1 somewhere. Now R1 is mapped with S1. R1 is K. Somewhere here is a K. Right? So K is mapped with 0. So it will be this point. R2 is mapped with S2. So K is mapped with, what we can say, K is mapped with, R2 is mapped with L minus 1. So K itself is again mapped with L minus 1, right? So it will be a straight line like this and then this. R2 onwards, then we will get, because once you reached L minus 1, after that you cannot exceed because you have a limit of that many bits. So it will be like this. This is the transformation. Actually, what will happen? You have 2 points, right? So that points are joined. Okay. Again, we are not going to. This is a special case of your piecewise linear transformation. Here also you can see that this is a piece. Again, there is a piece, and again there is a piece of a line. Okay. So that is how this is a general diagram, and that goes to this. And of course, implementation wise, we no need to go for thresholding using this piecewise linear transformation. Okay, that we can implement in our method, but you should be able to see pieces in the thresholding operation as well. Okay, so comfortable with thresholding operation? Let me show you that in the this slide so that it will be clear. In case not clear, stop me. This is what I was talking about, right? So R1 is mapped with S1, R2 is mapped with S2, right? R1 is equal to R2, S1 and S2, then it is a thresholding. Um, R1, S1 is R minimum 0, that is the minimum value 50. 50 is mapped to 0, 100 is mapped to 255, then it is a contrast stretching. What is the definition of contrast stretching? It is a process so that the available range of intensity is getting expanded so that it is available to full intensity range. What is the full intensity range available? 0 to 255. So I will expand the available intensities 0 to 50 to 100 to the full range of available intensities. Is it clear, everyone? So this is what also you are going to perform in the laboratory, contrast stretching. You have to do. You will take a low contrast image, right? And you will enhance them. So this is that operation, contrast stretching, and this is thresholding, right? So we will perform this. Will you be able to find out the equation? Suppose I say, if I will give you this image, what you will do first of all? First of all, you will check what is the minimum value, what is R mean. I will give you one image, then you will find out R mean first. Then you will find out R max. That you will observe your image and you will find out R min and R max from that. Then you know R min should get mapped to 0 and R max should get mapped to 255. Now, do you have equation of a line? Can you find out equation of a line if you have 2 points? If you have 2 points, can you find out equation of a line? Right? So once you have equation of a line, then what you have to do? It will be like y is equal to mx plus c. What will be your x here? M and c you will be able to find because of 2 points available. What will be your x here? What will be the value of x? This is my image. I have this type of, sorry, I have this type of line. If I want to, this point is available, this point is available. I found this equation of a line. Then what will be the x? What x will represent here? Yes, that is value of input, value of the current pixel. So I will take this as a x. Then what? How will I find s? How will I find output? How will I find this image? So I will take x as my current input, current pixel value. Then I will apply that as x here. Then I have m and c values. I will have that equation. I will find out y. So that x value should be replaced with this y value. Comfortable. In that way, I will perform this over entire image and I will be able to get this image. Are you following the procedure? Great. So otherwise, of course, you are going to do it in your own way. Uh, yes, as Yash says, it is 225. Jolit says it is 240. So I may think, okay, it is 230 around. So what we will do, it is trial and error process. It is subjective, right? And I told you that everyone has to try in this, right? So that is okay. I agree. But it is near to 255. Every one of us are agree with that it is near to 255. Now, what is the lower bound? That can be a separate question, or that can be again, even though even though 240 works, but yes, no, I want some more information here as well. So he can even start with 225. Someone of you may start with 220. That's okay. But yes, this is the range of intensity that I am interested in. So what I will keep, I want to suppress all other. So what kind of transformation I will apply? Can you tell me? So what I am having, I want to keep only those regions. So what kind of transformation I will apply? So I will take my input from 0 to 255. This is my input. I'm not writing R and S every time, but this is input. This is output. Okay. What is your plan? You want to enhance this. So want to make them white or want to keep them as it is? What is your plan? Again, you are the judge. You are the user. So you have to tell me. Okay. I am interested in this region, right? So let us take any case of that. Just tell me which case we want to try. I want to enhance this. That means I don't want to see other intensities. So what should I do? How can I do that? I don't want to see other intensities. What to do? What should I do with intensity? If my input intensity is say 0 to 225, let us take the case of 225 to 255. Okay, because it is a larger range, so that I will be able to draw it easily. Right? So tell me what to do. What is your plan to do? What will you do to intensities from 0 to 225? I want to suppress them. What do you want to do with that? Do you understand how to suppress? What is the meaning of suppression? Suppression is what that I want. I don't want to see them. What is your suggestion? What to do? How to is a separate question. Yes, let us make them. Um, Make the tumor darker, brighten the rest. That is what her suggestion is. Vishal says make 0 to 2 to 5 is 0. Rahul says decrease the intensity. Let us try them all one by one. We will try them one by one. Okay, I agree. I will start with Vishal's suggestion because it is easier to plot right now. Okay. So yes, that is also valid suggestion. Again, I told you it is very subjective. See here also we obtain various suggestions, right? Because you all are having different idea of making it highlighted. That's okay. That is very obvious, and that should be right. So okay. So let us 0 to 2 to 5. Let us make them 0. Uh, yes. So I am coming to your point, Priyank. I'm coming to your point, Priyank. What we are having here is 0 to 255. I'm making them 0, right? Now Vishal has not suggested me what to do with 255 to L minus 1, but Priyank has suggested that. What he suggested that if it is 2 to 5, output should be 10, and if it is 240, then make it uh, 240 kind of thing. So this is what his suggestion is. I'm not sure whether many of you will like that or not, but this is what he suggests, and it is his application. We can go with that, right? So this is a combined solution of that Vishal and Priyank, right? So all of you are comfortable what we did here, this is 255. I made it output 10, and if it is 225, then output was 240, right? So what actually I did, which intensity range I highlighted, whether this is highlighted or not, whether it will serve or not, but according to their requirement, I perform some operation. This is what my this is what this which kind of if I will draw it, this is what my transformation is. This is what my transformation is. What which range of intensity I highlighted? Which range of intensity I highlighted? Can you tell me? the range of intensity that we worked upon was R1 to R2, 225 to 220, 255. Others we suppressed, right? We highlighted this range, right? By changing it, sometimes some of you may change. Okay, you suppressed this. That is okay. You made it. Some of you may say, okay, up to 255 you made it black, but after that don't go with this transformation, because again it will bring the darker values into picture, right? I don't want to keep my tumor darker. So many of you may suggest up to this make it black and suddenly make it white like this, right? Of course, I hope you will understand this is what I wanted to plot, right? Suppose the intensity range available of this tumor, assume that intensity range of this tumor is, say, I'm changing the range. For my one more case I want to cover, 220 to say 240. This tumor has intensities in the range of 240, 220 to 240. So how this type of transformation will look like? So it will look like, it will look like from 0 to 220, make it dark, that is make it 0. Then 220 to 240, make it brighter. Brightness can be 220, 225 or higher, that is your I mean 225 or any other value that is of your choice, 240, 250, whatever you want to keep, and up to this, like this. So this is how, this is my 240. So how my this outer range can be L minus 1, that can be your choice, right? I'm keeping like this intensities are made, say, 250. All other intensities are suppressed to 0, right? So this is 250. And which intensities I have kept? This to this. That is 220 to 240. How my transformation looks like? It looks like this. Which intensities were highlighted? These intensities were highlighted. Now we are going for make the tumor darker, brighten the rest. That was her suggestion. How that will look like? If I will go for make the tumor darker, that is what his suggestion was. So brighten the rest. So all if intensities up to 255 are there. So up to 220 make it bright. From 220 to 240 make it dark, and 240 onwards make it again bright. Harsh, is it making sense to you? Should I plot it properly or clear with? Okay. Yes, Rahul suggested that decrease the intensity. So again, here also, Rahul, is it solving your purpose, or you wanted to say something else? Solved. Okay, so what is that is what my point is. Like some of you may think of that I want to highlight the range of 220 to 240, but I want to keep them as it is, because if I make them 250, actually I am losing the information from 220 to 240. All of them are 250, that means which pixels were darker, brighter, I lost that information. So some of you may say, okay, make other intensities darker in that particular range, keep them as it is. So this will be equation of a line at what we can say at 45 degree exactly, and then again make them darker. So this kind of uh, transformation is also possible. What we did, the particular range we kept it as it is, otherwise we made dark. Some of you say, okay, intensities in that range, keep it as it is, otherwise make them bright. That is okay, right? So different, all possible solutions are there, but what is here the heart of this entire issue is that certain range of intensity is highlighted. Okay. So that is what intensity level slicing. I sliced my image based on intensity. Certain range of intensity is highlighted because it is sliced, or rather it is treated separately, or in a special manner. Highlighting specific range of intensities in an image is intensity level slicing. What are the options that we have? All values of interest, make them white or black. Other values of intensity, make the other color, maybe dark gray, maybe black, maybe if this is white then black, if it is black then white. Other option what we are having is all the values of interest are um, value of interest are brighten or darken. Other intensities are kept unchanged. It is also possible that if I don't, if I want to keep this tumor white and rest of the image as it is, right? Or I want to keep this tumor black and rest of the intensities as it is. That is also possible, right? So all other things are possible. So here you can say the range of intensities from A to B, brighten. Other intensities are darkened. Here, rest of the intensities are as it is. This is bright. See, that depends on what kind of application you have. So, any doubt in this case of intensity level slicing? Okay, so assuming that you are comfortable with intensity level slicing, here they have shown that region. This region is of interest. Then you have to find out the range of intensity available here, and you will say you will have like we will make them white and others are black, or you will keep this as it is. You will see these two colors are same, this and this is same, but still it is highlighted because background is darker. We change the background here. We are not keeping the background as it. Background is darker, but these intensities are as it is, so that I should not lose my information, right? So you may say, okay, but why these values are existing? This is not of my interest. Can anyone suggest me the reason of this? Why these are there? Yes, they are also in your range. That's why they are also highlighted. That belongs to the range. That's true, and that's why it will be highlighted. So, if you want only this, now further processing that we are going to study in the next upcoming lectures is also needed. So, this is not totally clean, but most unwanted information is removed. If this is also unwanted, we can have some more processing, and then we can go for that. That we will see that which kind of processing are possible. Okay, so this is all about intensity level slicing. Now, next topic is that bit plane slicing. We have completed this too. Now we are going for the bit plane slicing. Bit plane slicing is okay. I shall give you a smaller example so you will quickly understand it and you will be able to move it fast from this. Assume 3 cross 3 image. How many pixels in 3 cross 3 image? How many pixels in 3 cross 3 image? See, it is very important. That's why I'm asking. Okay, that is 9. Okay, and if I say it is 3-bit image, then what is the difference between 3 cross 3 image and 3-bit image? What is the difference between 3-bit image and 3 cross 3 image? Range of intensity. What can you elaborate that? I need them. What is what? Yes, it will be 0 to. Okay. Can a 3-bit image be 5 cross 5? Can a 3-bit image be 5 cross 5? How many pixels will be there then? 25. And what will be the values of the range in that all 25 pixels? If it is image 0 to 7. Okay, that's good. So you are very much clear with the case. True. Now this is by 3 cross 3 3-bit image. So intensity values are possible are 0 to 7. So somewhere 7, somewhere 6, somewhere 5, somewhere 1, 1, 2, 3, 4. Suppose this is my um what we can say is my 0 to, I mean 3-bit 3 cross 3 image. If I represent it in bits, what will be bit representation of this pixel? It will be 0, 0, 0. That will be 1, 0, 1. This will be 1, 1, 0. 0. Are you following this? What I am doing here? I am just writing pixel value in binary. Tell me binary value of this, Kriti. This pixel. Yes, it is going to be 1, 1, 1. 0, 1, 1. Okay, in that way, I hope you will understand 0, 0, 1. 0, 1, 0. And this is 1, 0, 0. Now, what is bit plane slicing? What is bit plane slicing? Extract all bits individually, like extract all MSBs from all the pixels, extract sixth bit from all the pixels, extract fifth bit from all the pixels. Having 8 bit, so I will extract all LSBs from all the pixels. I will extract first bit from all the pixels. In that way, whatever is created. So suppose I am extracting MSBs from all the pixels. How it will look like? How it will look like? This will if suppose if I am extracting MSBs from all. So how it will look like? This will be 0. What will be value of this? If I am extracting MSBs of all the pixels, that means I will take MSB of that is most significant bit of this pixel value. What will be this value here? 1. What will be this value here? MSB of this pixel 1. Right? What will be this value here? 0. Okay, here 1. What about this? 0. Here it will be 0. What next? 0. What next? 1. True. So this is my plane. This is my highest bit plane because it is 3-bit image. That's why this is my highest bit plane. What about intermediate bit plane? Can you tell me what will be the value here? If I am, this is MSB, this is intermediate one, this is LSB. Consider this is LSB. For this 0. Okay. Alright. This value is 0. What about this? This is also 0. What about this? 1. What about this? 1. What about this? 1. 1. What about this? 0. 1. 0. And so on. You can understand for LSB. I'm not writing for LSB. I hope you will understand for LSB. Okay. Then all LSBs are going to extract. So if it is 8-bit image, how many bit planes are created? If it is 8-bit image, how many bit planes are created? 8-bit image, how many bit planes? Each bit there will be 1 bit plane. What will be the size of bit plane? How many cross how many? What will be the size of bit plane? Dimension. Okay, same as the original image. True. Here it is 3 cross 3, same as the image dimension. That's true. It is absolutely correct. So, um, 2 points here. Number of bits. Three. If I say 3-bit image, that means 3-bit planes. 3-bit 3 cross 3 image, that means 3-bit planes of size 3 cross 3. Okay. When I say 3-bit image of 5 cross 5, that means 5 cross 5 bit planes of 5 cross 5 bit planes. Such 3-bit planes will be there because for the MSB, LSB, and intermediate bits. That depends on the number of bits, right? Okay. Uh, Fine. Now, one more question. Okay. Now, can you tell me which colors are? Suppose if I have in my input, if I have two values only, 0 and 1, right? So it is a logical array. This is a logical array. Just two binary values are there, right? So 0 will represent a black color, 1 will represent a white color. When we give input to IM shown, it has only two values, 0, 1. If it is in the range of 0 to 1, then 0 value is mapped to 0, 1 is mapped to 255. We will see that too. Okay. So like you will feel like if I am having 0.5, it will look like a gray color, like similar to 128. Okay. So that you will observe. So can you tell me what will be the color if I use IM show and I'm storing this bit plane to some variable X? I'm storing the MSB bit plane, okay, which is having size 3 cross 3, right? So I'm storing it as a variable X and I'm writing IM show X. Which color I will be able to see in that IM show? IM show takes, if it is two inputs, 0 and 1, 0 is mapped to 0, 1 is mapped to 255. We will see that. But which colors will be visible in this? Yes, it will be a black and white image. It will be a black and white image. True. While this will be, original image will be a grayscale. So these are the points that are needed. Now you may say, okay, we understood that bit planes, but why you are interested in slicing them? What to actually obtain by slicing them? What was the purpose? So that we have to understand now. But what is bit plane is clear to you now. So what we have to do? All the intents, we have to slice the available bits, right? From bit plane 0, which is least significant, to bit plane 7, which is the most significant bit plane. Okay, in that they have taken one image, right? And they have created 8 bit planes because it is 8-bit image, and it will give us the bit plane related. This is related to LSB, and this is related to MSB bit plane. So what they did, that they took every pixel here, they took its 8-bit representation, that 8 from out of 8 bits, they took the last bit of all and they created this second last bit of all, then they created this, so on, and they took MSB of all and they created this. And certain interesting, so what is this? This is actually a black and white image, though it is looking not a clear, it is not clear one. The laboratory will see and it will be a black and white image, right? Created by extracting MSB bits of all of this. Okay. So can you tell me now, if I am representing a pixel using 8 bits, higher order bits of that pixel value represents contains foreground information or background information, and lower order 8 bits, which are this one, lower order bits, which are this one, contains foreground or background. Question is, like higher order bits, foreground information is stored where? In higher order information or lower order bits? Yes, foreground information is stored in higher order bits. True. Okay. So suppose I just give you, I just store 1 bit instead of 8 bits. I just store one bit, and if I just give you that one bit and you reconstruct out of that one bit, you will get this image, right? You will get this image. If you will use it in IM, if you will use it in IM show, you will get this, right? So can you understand which image it was? You will easily understand that it was an image of a dollar. So if it is your requirement, if you don't want to have this background information, this information is not available here, right? So if you don't want that information, this background information and all those information is not much required, right? Then you just need to store one bit. Okay, some of you say no, it just that less information is not good. I need this information. This is useful to me. This some information is there. I need them. So what you can do? You can take this bit, you can take this bit, and you can take this bit. You can store only these three bits. Why to store these unnecessary bits which are not useful to you in your application? I am not saying that they are not useful in any application, right? But possibly that if you are storing this much information now, instead of storing 8 bits, if you are just storing upper 3 bits, then that will be sufficient for you when you reconstruct out of them. It is sufficient for you to that much information is sufficient for you. Then unnecessarily for per pixel you can save 5 bits, which are unnecessary information for your application. That's why what happens that generally in any application, they see that suppose I want to compress that, I will first decompose my image into this type of bit planes, and I will see how much information, how many bit planes are useful to me, right? And those bit planes are only considered, and other information, other bits are suppressed. Only those many bits are stored, and we can save certain bits per pixel, and hence size can be reduced. Okay, so how to so that is, I will show you that all things. First of all, how to obtain plane. So first of all, you have to extract all MSBs, or rather, if you want to go in other way, what I want, when my MSB will be 1, in which range of intensities my MSB will be 1 if it is 8-bit image? In which range of intensity my MSB will be 1 if it is 8-bit image? Yes, so from 128 to 255, if my intensity is in the range of 128 onwards, I should make it 1. Otherwise, I should make it 0. That is. So that's why it is intensity level slicing. From 0 to 127, make them 0. 128 onwards, make it 1. So can you see here intensity? I mean, can you see here piecewise linear transformation, right? That is why this is how you can extract for every case. In which case my seventh bit will be 1. So again you can find out the intensity range. In that range, um, intensity the my MS seventh bit will be, or rather I should say, if I am numbering from 0 to 7, then sixth bit. If I am numbering from 0 to 7, then sixth bit will be 1. So I can find out the range of intensity in which sixth bit is my 1 value. So I can have this type of slicing, and that's why it falls under the category of piecewise linear transformation. Like here it is given 7th bit plane. Here it was 8th bit plane if you are numbering from 1 to 8. 7th bit plane, here it is assumed that numbering is from 1 to 8, or otherwise if you are numbering from 0 to 7, you can assume as 6th bit plane. That's okay. So in this range of intensity it is 1, otherwise 0, right? Border value of the original pixel is 194. 194 is represented in binary like this. That means lowest is here, this border will be 0. This border is 1 here. So you can see the lowest is 0, then 1. Border value is 0, 0, 0, 0. 4 times 0. Then border value is 1, 1. White and white. I hope you are getting this region we are talking about. Okay, so this is how bit planes are created. Already you understood in 8 bits. Why it is useful? This is your original image, right? You can just use 2 bits and combine them, right? And you can get this image. Of course, it is not containing this information, not containing this information, see, right? But anyway, still it is much decent. If it is okay for your application, you can just store out of this 8 bits, you can just store these 2 bits. Don't store them because you don't need them, so you saved some value. But some of you say, no, in my application I need some background information, so they can store 3 bits. Some of you say, no, I want even more background information, right? Here it visually not clear because but still here you can see here this information is quite smoother, right? This were dots were there and here it is quite smoother because one more uh, intensity value is added, so um, transitions are smoother comparatively, right? So that is more information is added here. Some of you say, no, I want all the information. Then you cannot suppress anything. Then you have to keep all 8 bits. So what is the use of bitplane slicing? So bitplane slicing is used in compression part. Like if you want to compress, so you are saving per pixel, certain bits are saved. So useful in compression and storage, right? How to, suppose I am storing this one only. So I have stored for this border I have stored one, right? I'm not storing rest of the bits, right? So suppose for border value I store one. Playing, what I need is that one and other value should be 0, 0, 0, 0, 0. This is what my desire is, right? I'm suppressing this means what I'm storing this too. But when I display, I should display it like 1, 1. So that color should be, though it is not 194, it should be like 192. I'm suppressing this information, right? And this is so how to reconstruct this? So whatever value that is equivalent to 8th bit should be multiplied with 2 raised to 7. Whatever bit is equivalent to this, what you can say, a 7th bit should get multiplied with 2 raised to 6 and added them should be my desired value. That is how you will get this value. Okay. So reconstruction is obtained by whichever bit plane you are talking about, -1, 2 raised to that value. Suppose I am working with 8-bit plane, then it should be 2 raised to 8 minus 1. Plus, if I am working with, so are you comfortable with reconstruction? Should I take it again later in the next lecture? Should I start with reconstruction part, or are you comfortable with what I told you? Clear, na? What about others? Okay. Okay, great. So we are stopping here with reconstruction part. Definitely laboratory, in the laboratory session we will discuss. So the next lecture onwards we'll go with the image histogram. Okay. So fine, that's good. So we will meet with the next topic in the next lecture.